Common challenges in the application of online PD technology. The focus of this, though, is really looking through the different types of challenges that you might face. So the first side we're going to look at is the technology challenges. And here, really, this is looking at the type of equipment that you can use and how you can apply it to your network. So it's more your planning of the equipment and planning of the instrumentation or the systems that you would use in your effort of detecting PD online. So we'll look at the sensor types, things around installation of sensors. We'll look at PD and electrical noise and what you need to consider on that side of things before applying a particular technology. We'll look at permanent monitoring versus spot testing. Then we'll move on to practical management challenges. So here really we're looking at it from an asset management point of view. And as an asset manager, what type of challenges you need to consider when interpreting results of a technology or when deploying resources, deploying equipment in your network. So we'll look at PD levels and how PD levels should be integrated into your decision making. We'll look at false positives and the impact that that might have on your operation. We'll look at expert resources and technical knowledge and how you should try to integrate that into your asset management program as well. Then finally, we'll look at advanced challenges. Now, I was having a discussion with my colleague earlier on. Advanced challenges, I could list 2 or I could list 102. When it comes to advanced challenges, these really are different considerations when you come across unique situations. Or common situations, in fact, but I suppose it's where you need to have a little bit more in-depth knowledge of application of PD. So I've taken just 2 as an example in this case, but like you said, there is 102. And if in fact you have a specific advanced challenge, please feel free to send us an email and we'll happily discuss. I'm looking at 2 really. One is PD location and some of the challenges across PD location. And then the other one is network configuration and how the configuration of your network might affect your detection of PD. So the first thing we'll look at then is sensor types and installation of sensors. So what's the problem? First problem is what sensor should I use with what asset? And the other problem is where can I install and where can I apply my sensors? The first mitigation step, if you like, is really to research and to look into what sensors are firstly optimized for different types of assets. I've looked at specifically on cable PD, I've looked at specifically on switchgear PD, and highlighted the different types of sensors that are typically used. And that word is important, typically is important. The sensors that are typically used for different types of assets. So for example, for air insulated switchgear, typically airborne acoustic or ultrasonic sensors are used, as well as CC-TEV sensors, transient earth voltage sensors. For GIS, gas insulated switchgear, typically UHF sensors are used. For underground cables, typically HFCT sensors are used. And for outdoor switchyards or overhead line, bushing connectors, etc., parabolic, which is still an ultrasonic type of sensor, but with a parabolic dish, is typically used. So there's a variety of sensors, standard sensors that are used for different types of equipment. And it's important, before making a decision of what to apply in your network, important to understand the types of sensors. The other thing then to look at, after you've decided what types of sensors can be used, look at installation options and barriers. So you've got to then look at how that sensor would apply to your equipment. Every piece of switchgear is different. Every different types of cable networks are different. So you need to consider the limitations of the sensors and how it can apply to your network. So for example, for cable PD, HFCTs, for example, HFCTs come in different shapes and sizes, different dimensions. And if you're installing a HFCT around the core of a cable or around an earth of the cable, the dimensions of these can be different. So you may need a large HFCT, you may need a small HFCT, you may need a polymer-based, you may need a metallic HFCT, very much different options that you can have for HFCTs, for example. When it comes to air-insulated switchgear, more modern air-insulated switchgear like this can be sealed. So whilst that's not a problem for a TEV sensor, because a TEV sensor can be installed on the outside, we need to carefully consider where our ultrasonic sensor can be installed. So we can see the ultrasonic sensor in this picture here. Does it need to be installed internally? Do we have any problems with that? Is there a shutdown required? And if you're going to shut down and install a sensor inside a cable termination, maybe you need to consider not just running the cable out, maybe you want to install a connector so that you can use not just a monitoring system, you can use a spot test equipment, etc. Maybe you need to look at alternative options for sensors like pre-installed sensors. So This middle picture here is an example of an Iris in the USA, IRISS, where they've got an example of an inbuilt ultrasonic sensor inbuilt in one of their windows. So then the windows are designed for being installed on switchgear. So the window's permanently installed, and indeed you can get these where you can combine infrared and ultrasonic, so that you can have two different types of sensors. So you can use it in that way. So maybe you need to look at that, look at different options for pre-installed sensors as well. And then finally, do you need to look at alternative sensors? And I'm intentionally vague with that statement, alternative sensors. But I suppose what I mean really is, in some instances, you can use some of these sensors for different applications. So for example, HFCTs, if they've got particular characteristics, so some of the HFCTs that IPEC manufacture, for example, are specifically optimized for detection of PD inside switchgear. So maybe you just need to, if you've gone through these steps and you can't use the standard types of sensors, maybe you need to look at alternative application of sensors. So like I said, HFCT used on AIS or TEVs used on GIS, etc. But obviously, when you're looking at alternative sensors, make sure you're speaking to an expert in this field, and also make sure your understanding of the limitations of applying different technologies. Next challenge, PD and background noise. So our problem is that PD sensors will detect environmental noise. Every PD sensor will detect background noise. That is just a fact. The noise sources, so where the noise comes from, can vary depending on the sensor type. Typically, radio masts, mobile phone masts, faulty lighting, fluorescent lighting inside substations is a common cause of TEV noise, particularly. Other substation equipment, other industrial machinery could all cause noise interference. Noise sources can be much larger than PD as well, which is the other important thing. So, of course, you will always get a level of background noise in a substation, and sometimes your PD may be higher than that background noise, but they can and often are much larger than the PD. And particularly when we look at something like underground cables, it's very likely that you will see very high noise in underground cable network, which could mask the PD. So what mitigation can we have against noise interference in our measurements? Well, there are multiple methods to mitigate against this, and the ones that are most commonly used depend on the complexity of the equipment. But all equipment should have some method to differentiate PD and noise. So it's not acceptable to say that because this equipment is simple, we don't have any noise rejection. In this day and age, and with the equipment available on the market, that is unacceptable now. Maybe 15 years ago, that was an acceptable thought process, but now no longer that is. Just because your equipment is simple, maybe it's a handheld equipment, doesn't mean it cannot have some sort of noise rejection, some sort of ability for you as a user to differentiate PD from background noise. A standard way of noise rejection is phase resolved partial discharge. So phase resolved partial discharge, like we see in this top right diagram here, you can see the PD pattern in the power cycle. PRPD is a very, very effective way to differentiate PD from background noise. Ideally, a PRPD would have depth. And what I mean by depth is the ability of a PRPD not just to look at a single power cycle, but to look at many power cycles on top of each other. And once you do that, you can then highlight the areas where the signals are detected more and more. And so you can then, I mean, this is not the best image to represent this, but you can see we do have a depth scale on the right-hand side. So we can see where the signals are more intense in the power cycle. And what that enables is if we have a sort of a noise that's occurring randomly across a power cycle, which typically noise does, but we have a PD occurring specifically in one location on a power cycle, which typically PD does, as we know. With the depth, it means that we've got a better ability to differentiate PD from background noise because we can see the PD pattern in the power cycle. So that's the standard way of PD and noise discrimination or differentiation. And in my opinion, in IPEC's opinion, that should be the minimum. Any PD equipment you're buying should have the ability to view PRPD. It doesn't matter if it's a low-cost handheld equipment, they should have the ability to view PRPD. The other side then is the more advanced. If you're using more complex equipment, maybe I suppose in my example here on the right-hand side, permanent monitoring systems, advanced high-resolution data acquisition, and algorithms to differentiate PD from background noise. When you're using a more advanced piece of equipment with high data acquisition, like typical online permanent monitoring systems may have, you're then able to use algorithms and you're able to look down at individual PDs. So you don't need to look at the wide view of a PRPD like this. You can look very much in depth at individual PD pulses and use more advanced algorithms. So instead of trying to see the PD in the noise, which essentially is what you're doing with a PRPD, with a more advanced algorithm, you're able to pick out the PDs from the noise. So this diagram, and again, this is from our permanent monitoring system, very high resolution data acquisition, 100 megasamples per second, 14-bit resolution, which means that we might have very large rolling background noise, and we can use wavelet algorithms to pick out the individual PD pulses from that background noise. The main thing to take away from this is there's two types of PD and noise rejection: a more standard or simple way, like the PRPD method, and a more advanced way, like an algorithm-based, very advanced automated solution. Both methods are useful for differentiating PD from noise, and you should have some method in every type of PD equipment you use. Challenge 3, monitoring or spot testing. So the problem is, should be, so again, sorry for my typo, this is the, should we be permanently monitoring for PD or spot test? What should we do? Permanent monitor or spot test? And is there a risk of missing PD if we only do intermittent spot tests? So what's the mitigation? Spot testing and permanent monitoring both have their unique advantages, in fact. And there is no one solution for all of your assets. It may sound obvious, but I think it's an important note that you cannot just decide on how you're going to test your assets and roll that out everywhere. There is different types of assets in your network, and you will need to use a combination of solutions. That is a fact. The regularity of your spot testing needs to be taken into account as well. You've got this problem here of, is there a risk of missing if we only do intermittent spot testing? Well, the way to address that is, if you are using a spot testing method, how regular are you spot testing? Now, intentionally, I'm not going to give you an answer to this question, how regular should you spot test? Because actually, it's probably more applicable to the asset management side that we'll come onto in a moment. But every network is different. Whether you spot test every week, every month, every 3 months, depends on the type of network you're running, depends on the resources you have available, and depends on the priority of the different assets across your network. If you're only spot testing, then naturally you'd expect your higher priority assets, whether that means they're a city center based asset, whether that means they're supplying a key production line or production facility, you would expect to more regularly test that for PD. Or if you're permanent monitoring, maybe that's where you would deploy your permanent monitoring. So let's just take a moment just to consider the two different aspects of spot testing and permanent monitoring, what the advantages are. And really what you need to do is you need to weigh up the advantages of both of these types of things. Maybe conduct a return on investment of both of these types of technology, looking at the different classifications of your assets in your network. So spot testing, for example, very quick to deploy. Permanent monitoring, on the other hand, is a bit slower for deployment. Spot testing can be deployed or used in many sites, whereas permanent monitoring typically is deployed in one site. One problem with spot testing, a high labor requirement. So when you're spot testing, you need a lot of resource planned and a lot of manpower to go to site and conduct testing. Whereas on permanent monitoring, there's a much lower labor requirement once the system is installed. Spot testing generally is more manual, and by manual I mean the method of data interpretation. So although you may have your noise rejection and your PRPDs built into a handheld device, it is still manual. You still will need to review that data. Whereas permanent monitoring systems are much more automated. They will do the data analysis for you. Spot testing might be a lower cost per unit, and permanent monitoring might be a higher cost per unit. But importantly, both of those aspects need to be considered in relation to the cost effectiveness of the equipment. So while a spot test device is cost effective in the short term, a permanent monitoring device is cost effective in the long term. So it may be cheaper tomorrow to spot test a substation, but if you want to monitor over the next 10 years, maybe sending an engineer to a substation every month after a few years becomes more expensive than the initial outlay of a monitoring system. I suppose to a certain extent, I didn't answer the question monitoring or spot testing, but what I did is I gave you some tools that you need to consider. There is no answer that fits all networks. There is no answer. I cannot give you an example from one customer that applies to the next. You need to assess all of these. And in fact, the nice thing is I'm coming on to asset management now, and it feeds almost directly into that, how they fit together.